Hardy-Weinberg Equilibrium dates back to 1908. This equation was created by G.H. Hardy, a mathematician at Cambridge University, and Wilhelm Weinberg, a general practitioner and obstetrician.
The Hardy-Weinberg principle states that allele and genotype frequencies in a population will remain constant from generation to generation in the absence of other evolutionary influences. Hardy-Weinberg is applicable to a gene pool if there are no mutations, no migration, no natural selection, there is a presence of random mating, and the population is large.
The Hardy-Weinberg equation is p squared plus 2pq plus q squared equals 1. The p squared value represents the homozygous dominant genotype. The q squared value represents the homozygous recessive genotype, and the 2pq value represents the heterozygous genotype.
How often a specific allele occurs in a given gene pool is known as the allele frequency. By taking the square root of p squared, you get p, which is the dominant allele frequency. By taking the square root of q squared, you get q, which is the recessive allele frequency.
The Hardy-Weinberg equation must always add up to 1 or 100%. The p and q values should always add up to 1 as well. Because we are talking about a population, the two frequencies should add up to 100% of the population.
Because p represents the dominant allele and q represents the recessive allele, pq represents the heterozygous genotype.
Let's try a practice problem. 16% of the population is unable to taste the chemical PTC. These non-tasters are recessive for the tasting gene. Part 1 of the question asks, what percentage of individuals in the population are tasters? This is asking for the combination of the homozygous dominant and heterozygous genotypes. Since we only know the percentage of homozygous recessive genotypes, we simply subtract 16% from 100% to find the answer to part 1, which is 84%. Part 2 of the question asks, what is the frequency of the dominant and recessive allele? The original question states that the non-tasters are recessive, which is q squared. This means that we need to find out what the q squared value is. Once we convert the percentage into a decimal, we find that the q squared value is 0.16. To find the q value, we must take the square root of q squared. When we do this, we find that q equals 0.4. Since p plus q must always equal 1, we simply subtract 0.4 from 1 to get the value of p, which is 0.6. The final part of the question, part 3, asks what percentages of the population are heterozygous for the trait. As we discussed before, the percentage of the population that is heterozygous is equal to 2pq. To solve for this percentage, we plug the p and q values that we found earlier into the equation 2pq. When we multiply these values together with 2, we get the number 0.48. To get the answer the question is asking for, we must convert the decimal into a percentage by moving the decimal point 2 places to the right, resulting in 48%.
Thank you for watching and learning with us.